Space, the final frontier. Since the dawn of humanity, we've gazed up at the stars and wondered about our place in the cosmos. The allure of the unknown has fueled our desire to explore the vast expanse beyond our planet, but how do we break free from Earth's gravitational grasp? The answer lies in the incredible power of rockets. Rockets are feats of engineering that have allowed us to send humans into orbit, land on the moon, and explore distant planets with robotic probes. They are the vehicles that carry our dreams of space travel. But have you ever stopped to wonder how these powerful machines actually work? The science behind rockets might seem complicated, but it's based on some fundamental principles of physics. In this essay, we'll delve into the fascinating world of rocket science and uncover the secrets of how these incredible machines propel us towards the stars. Get ready for a thrilling ride as we explore the power and ingenuity of rockets. To understand how rockets work, we need to start with a fundamental law of physics, Newton's third law of motion. Sir Isaac Newton, a brilliant physicist, stated this law simply: for every action, there is an equal and opposite reaction. Imagine you're standing on a skateboard holding a heavy ball. If you throw the ball forward, what happens? You'll roll backward on the skateboard. That's Newton's third law in action. The force you use to throw the ball forward creates an equal force that pushes you in the opposite direction. Rockets work in a similar way. Instead of throwing a ball, they expel hot gas out of their engines at incredibly high speeds. This expulsion of gas creates an equal and opposite force that propels the rocket upward. The key to a rocket's power lies in its ability to create thrust. Thrust is the force that pushes the rocket upward, overcoming the force of gravity. But how do rockets generate this incredible thrust? The answer lies in controlled explosions. Rockets carry a mixture of fuel and an oxidizer. The fuel is a substance that burns easily, like liquid hydrogen or kerosene. The oxidizer provides the oxygen needed for combustion, as there's no air to breathe in space. When these two components mix and ignite in the rocket's combustion chamber, a controlled explosion occurs. This explosion produces a massive amount of hot gas that expands rapidly. This expanding gas is then channeled through a narrow opening called a nozzle. As the gas is forced through the nozzle, it accelerates to extremely high speeds, creating thrust. Section 4. Anatomy of a rocket. A rocket is a complex machine with many different parts, each playing a crucial role in its mission. Let's take a closer look at some of the key components. The heart of the rocket, the engine, is where the combustion of fuel and oxidizer takes place, generating thrust. These massive tanks store the rocket's fuel and oxidizer, which can be cryogenic liquids or solid propellants. Next, we have the powerful pumps that deliver the fuel and oxidizer to the combustion chamber at incredibly high rates. The nozzle is a carefully shaped opening at the bottom of the engine that accelerates the hot gas, creating thrust. This system uses computers and sensors to control the rocket's trajectory and ensure it stays on course. And finally, the payload. This is the cargo the rocket carries, which could be satellites, scientific instruments, or even humans. Section 5. Stages of a rocket launch. Launching a rocket into space is a complex and carefully choreographed event that involves multiple stages. Each stage is like a separate rocket with its own engines and fuel tanks. The first stage's powerful engines ignite, generating enough thrust to overcome Earth's gravity and lift the rocket off the launch pad. As the rocket climbs higher, it encounters air resistance. The first stage's engines continue to fire until their fuel is depleted. Then, the first stage detaches and falls back to Earth. The second stage's engines ignite, providing the additional thrust needed to reach orbital velocity. Once in orbit, the second stage detaches. If the rocket has a third stage, it will ignite to carry the payload to its final destination, such as a higher orbit or another planet. Section 6. The future of rockets. Rockets have come a long way since the early days of space exploration. Today, scientists and engineers are developing new technologies to make rockets even more powerful, efficient, and reusable. One promising area of research is reusable rockets. Companies like SpaceX and Blue Origin have successfully landed and relaunched rocket stages, significantly reducing the cost of space travel. Another exciting development is the use of three-dimensional printing to create rocket parts, allowing for faster and more efficient manufacturing. As we continue to push the boundaries of space exploration, rockets will continue to play a vital role in our journey to understand the cosmos and our place within it.